Alright, good day. So what we're going to look at next are the three most recent paper 2 structured questions on circle geometry. All of them are 6 marks because that question number 9 would be 12 marks. Half will be circle geometry, half will be the section 2 trigonometry, sine rule, cosine rule. So let's look at these. So in the diagram below, this is the most recent one, by the way, January 2021. In the diagram below, again, always good to read this. Like I said, A, B, C, D are points on the circumference. So I've seen 4 points on the circumference. Do I have a cyclic? No, because if you look, it's not joined here. It needed to be joined here to get a cyclic. So we do have a cyclic with center O. So we have a center of the circle. AOC and BOD are diameters. So we have some diameters on the circle there. And we also have parallel lines. So once we see the parallel lines, that means some of those old time rules for geometry could come back. And the rules with the parallel lines are corresponding angles, which are the angles in the same position, top and bottom. Alternate angles that form the Z shape, and we have interior angles with the parallel lines as well. So let me see what's taking place now for this one here. I'm just going to adjust it a little bit here. Right. So state the reason why angle ABC is 90 degrees. So this is angle ABC here, and that is your very first and most basic rule. We have angle ABC. I'm just highlighting it because we have a diameter and we form a triangle with the diameter. The angle in a semicircle is 90 degrees. So that's all. I could just state the rule. The angle in a semicircle is 90 degrees. Oh, by the way, realize we have no tangents here, right? So we don't get into those, what I call in the advanced rules with the tangents, right? Because we don't always have the tangents. So we done the first part, we get a mark. Determine angle BAC. So BAC, what makes this question a little more difficult is they didn't give me numbers. They give me numbers and letters, meaning I have algebra to use. But we could still do it because I have a triangle. The three sides of my triangle are 90 degrees plus 2p plus 3p, and that triangle should add up to 180. So 2p at 3p is 5p. So 90 degrees at 5p is 180. So 5p is 180 minus 90, and half of 90 is 90. So if 5p is 90, then 1p, 5 things cost $90. 1p will be 90 over 5, which is, in this case, 18 degrees, not dollars. But now that I know what p is, I could find all these angles. So if p is 18, then 2p is 2 times 18, 36 degrees. And even though they didn't ask for this yet, 3p will be 3 times 18, 54 degrees. And just to double check, 54 at 36 is 90, 90 at 90 is 180. So the angle they wanted was angle BAC. Angle BAC is 36 degrees, and I have a little work in to show why that angle was that amount. Next angle, everybody okay with that? As again, how they mix it with the algebra for the most recent question, which is something they like to do a lot of. Mix these questions, all questions, and that's why algebra is so important, right? Basic algebra. Angle Q. To look angle Q here now, that's the next angle they want. So you realize they don't have to always say BAC here. They could have said BDC. They didn't. They're calling it Q. They could call this R as well, which they did for the last part, by the way. So this one was a little harder to spot. The only reason is, and you'll notice this for the most recent questions, they bring in this rule into play. I told you it wasn't one of the more popular rules, and that's what CXC like to do. They notice, hey, everybody's always expect this rule or this rule or this rule. This is was one of the least popular rules, but as you'll see, this is going to pop up more than once in the last 3 years. So that's this rule we actually have here. Angles are coming out from the same point, and you might be able to see it. So I'm just going to turn the diagram a little bit, and I'll use my colors here. So this is the chord or the point that everything coming out from. One pair going to this side, and the same 2 points. Next pair going to this side, and we also have the same points going to the circumference. So wherever the circumference is going to be twice those as well, but whatever on the circumference, which is this rule here, and it's similar to this last situation here, these angles are the same, and the angle at the center is going to be twice as much. They didn't ask for the angle at the center yet, or not at all, but one pair go to the center, One pair go to the circumference, one pair go to the center, one pair go to the circumference. If both of them come out from the same point and go to the circumference, all these angles on the circumference are going to be equal. So since we just find out here was 36, then guess what? Here's 36 as well, and I don't really need to do any set of calculations for it, especially if I notice that rule. But the reason I'm mentioning it is, like I said, that coming more and more frequent. So like I said, they're making sure you know all your rules as well. So angle R now, so we just find out here's 36. This is angle R. Now they have different ways to find angle R, and I'll show you some of the different ways. So like I said, you have the option to use your the parallel lines, and in this case with the parallel lines, I need more colors again just to highlight. So the parallel lines, I have a Z shape. Don't forget these earlier geometry rules. And the nice thing about the Z shape is the alternate angle rule, that is, whatever inside here, the arms of the Z that must fall between the parallel lines, they're going to be the same. So guess what? Here's 36 degrees. That's how much R going to work out to. That's one way to get it if I want to use my parallel lines. Or if I had noticed that, and again, more colors, it had so much different ways for this one. This is a radius, and this is a radius, meaning this is an isosceles triangle. So once I find out here's 36, here's 36. Or, just like I had angles in a semicircle here, this was a diameter, and I form a triangle with the diameter. You realize we form a diameter with the triangle here as well. This is our next diameter with the triangle we form here. Meaning, here is 90. Because the angle in a semicircle is 90 degrees. And I have our next semicircle with the diameter here and our next triangle here. So here's 90. We find out here's 54. 90 minus 54, 36. So you see how all of those rules kind of intertwine to give me the same exact answer. And unusual for the exam, and a lot of people would probably be doubting themselves that all three answers end up being 36, but that's how it was for that most recent exam, and 6 marks in total for those 4 pieces. So we jump straight into the next one. January 2020 was the next one. So let me see what's going on with this one here for this next one. Right, and in this one here, the circle above has center O and the points A, B, C, and D lying on the circumference. A straight line passes through the points A and B. Right, so here, so this is not a tangent because it cut through the circle. Angle CBD is 49. Angle OAB is 37. So those are the different points that we have. And now I want to write down, so now that I have my diagram, let me look at what they was asking for. Again, 6 marks if you notice, right? Write down the mathematical names of the straight lines. So you see why those terms are important, because they have, those terms could pop up in the question as well. Right, so the straight line BC, so what we call a line that touching 2 points on the circumference, we call that a chord. We went through that when we went through the different pieces and parts of the circle. And they wanted OA as well. OA is a line from the center of the circle to the circumference. Even easier. We call that a radius. You get 1 mark each. So we have 2 marks out of the 6 already, just for knowing your terms. Now I know the radius would be easy, but don't forget what a chord is. And again, a segment is what the chord creates. So when I draw a chord, the piece, the area that it blocks off is called the segment. So the next part, determine X. So look, X here, but what do I notice? They already tell me this is a radius, a line from the center of the circle to the circumference. But look, I have an X radius popping out here, meaning I have 2 radii forming this triangle here with this next chord that B is would be a chord the line pierces through, so technically it will be a secant. But we have that triangle forming with this shape here, and because it's 2 radii that form the triangle, these 2 angles going to be equal. So because I know here's 37, this next piece is going to be 37 as well. I have 2 angles in my triangle, so I could find the third. So 37 and 37, both of them putting up 74. So he's going to be 180, take away 74. So this angle going to be sorry, I write the wrong piece. This angle going to be 106 degrees. And again, make sure and show how you get your different pieces as well. For angle Y, well, again, we have that rule popping up again. We had a diameter. So did they form a triangle with the diameter? Again, I'm going to use my color just to highlight. They did form a triangle with the diameter, meaning the angle up here is going to be 90 degrees. And now he put up 49, he put up 90, 90 at 49. So far I have 139. So he have to make up the rest. 180, take away 139. So my answer here is 41 degrees. This was a lot easier than what you normally get, but we don't know what we get in here every year, right? So for the last one we're going to look at, there'll be a June exam, because the last two exams that they had would have only been, for paper 2 at least, would have been a January paper. So now this was the most recent June paper that they had, and it probably is the hardest out of the 3 that they had so far. But let me take a look at it and see, right? So May 2019, and again, make sure and read the info that they give you. The diagram above shows a circle where we have a diameter. AC is a diameter. That's a big help there, because once I have a diameter, did they form a triangle with the diameter? We'll come back to that. The diameter also means they have radii. B and D are 2 other points on the circle, right? They are B and D they're talking about. And DCE is a straight line. It is not a tangent, again, because it has pierced the circle. Angle CAB is 28 and angle DBC is 46. And now let's see what they're asking for in the body of the question. Again, all these questions split number 9 in half. It's 12 marks. They split it in half, 6 marks. So what do I notice with my diagram? We can put it in one time. Because I have a diameter, do I have any triangles formed with the diameter? Yes, I do. So I have a triangle formed here, meaning this big angle here is a 90-degree angle, but I also have a triangle formed with the diameter on this side as well, making this, I also have, as a result, a 4-sided shape as well. But let me see if those things coming into play. So let's see. The first angle they want, DBA. DBA, spot on. That's what they wanted. They want this part of the 90. So if this whole thing is 90, this part is 46. How much this part? Because that's what this means. Both of these pieces going to total 90. We know one piece is 46. How much the next piece going to be? 90 degrees minus 46. 44 degrees. And again, I could put my work in there. 90 degrees minus 46. 44 degrees. 2 marks. Angle DAC. Where is angle DAC? DAC is this part here. How are we going to find that part there? So, remember what I told you? They're starting to bring back this rule a lot. So you have to watch if a lot of this stuff connected. So we having this situation a lot where from the same 2 points, a pair of lines going to come out. So let me see if I could highlight it again. So from these 2 points here, and let me see if I could finish this video before my neighbor blasts me out there. So from these 2 points, one pair going to the circumference, and from the same 2 points, a next pair shooting out and going to the circumference as well. Right? So again, it's similar to this one here, right? One pair shoot out this side, one pair shoot out this side. So these 2 angles going to be the same. So one pair shoot out here, so this angle is the same as where this one shoot out, which is here. So that means that this is 46, and you realize it didn't even have any big setup working for it once you know that rule though. Right? Could I have worked around it? I could have probably find all these angles, but it would have taken really long, and I'm not even sure to have gotten it. So that's why don't forget that rule, because like I said, in the past 3 years it has popped up more often than it has normally popped up. Last one, angle BCE. BCE is this angle on the outside here. So I have different ways to get it. What would I jump out at me? We didn't use the cyclic yet, so let me see if we could use the cyclic. So this big angle here opposite to this big angle here. Right? That's what I noticed. So 46 add 28, that is 74. So that means this angle opposite that, because opposite angles in a cyclic quadrilateral, this big angle here going to be 180 minus 74. So here going to be 106 degrees. But now this is an angle on a straight line. And a straight line, as we know, add up to 180. So if you put up 106, you have to put up the rest, which is going to be the 74, as you'll see. 180, take away the 106. So my angle going to be 74 degrees for that last part, just to show you how it would work. So again, you see how we use the cyclic again. Once you have a diameter, look out for your radii. With the diameter as well, look out to see if you have any triangles giving you that 90 degrees. But this is how you chip away at the question. For me, it's one of the questions to get easy, quick marks on, because you finish this in no time as well. But you have to know all the different rules. So check out the virtual package when I send it. And again, we finish circle geometry now.